On today's episode of Watch Jericho, we are here with an update that you guys have been begging for in the comments for about a year and change. The Car Crusher's final part. What is going on, guys? I am Watch Jericho, and today, like I said, I'm here with my dad. And a lot of you guys remember when we fixed the Car Crusher, we pretty much got that thing. Well, we had it running and everything like that. Yeah. It's a gigantic metal baler. And then we kind of went radio silent on it. And we told you guys we were waiting on parts. The parts are now here. And today we're going to show you guys how this pump works. We're not putting this pump together today because it's a massive process. But we're going to give you a quick walkthrough of everything that showed up for this thing, because it's a crazy amount of custom made German parts. Yeah. And it looks like this company used to be called Rexroth, but Bosch jumped in and bought them based on.
Yeah, it's a Bosch Rexroth pump, so it's a big garment out of Germany.
Yeah. So I mean, you would assume Bosch is going around buying up everybody, and it looks like this was one of them. So this is a monstrous hydraulic pump that delivers. How?
This delivers about 4,000 psi.
4,000 psi, and the motor.
Sure exactly. I think it's 4,000, or I know it's quite high. Maybe 4,200.
But it was running on 125.
125 horse.
125 horse motor. Monster.
Yeah.
So it's a really big pump. We're going to give you a full walkthrough today of how this thing works. Let's jump right in.
So a little bit of history on this unit. As those of you have seen the updates and the videos on the Car Crusher. We call it a car crusher, but it's like you said, it's a big metal baler.
Yeah.
And it's 500 tons, so it produces a tremendous amount of energy. The machine has 3 pumps on it. It has one double-ended pump on one end, and then this pump is on the other end of that 125 horse motor. So the 125 horse motor has a shaft sticking out each end. When we finally got the machine running to where
we'd call this the main pump, right? The other, what's
the high pressure?
The high. So, that's what it is. Yes,
so
yes.
If you name the pumps, we have the lowest pressure, highest volume, and it's a vane pump.
Okay.
So it just has vanes that are sticking out. So the vanes slide in and out of a rotor. This is the rotor out of this pump. And a vane pump, for those of you who haven't seen a vane pump, it just has a bunch of slots in it, like the vane pump on the front of a 350 or a 400 Chevrolet, right, on a turbo hydromatic.
Sure.
Or any, most automatic transmissions have a vane pump, and so there's a vane that sets in here, and so the cavity that it sets in is oblong, so it'll be big on one side, and it'll almost run up tight on this side. This is where the oil comes in on one side, it sucks it in as it rotates around, and then it pushes it back out. So it's almost in contact with the cavity on this side. Like I say, it's bigger on this side, and the vanes are free. Some of them are free, some of them are spring-loaded, so they stay out tight. But that pump can't produce a whole lot of pressure, because if the pressure gets too high in the pump, it can actually push the vanes back in, and oil can escape around the end of the pump, around the end of the vanes. So that's a vane pump. Anyways, you have your lowest pressure, highest volume, and that's made for moving that great big cylinder really fast when you're going to move it back and forth. Okay, and then when the pressure gets up to a certain point, the pressure starts to build, when it starts to bale some metal, then what happens is there's a relief valve that opens on this first pump. So as it opens, that just dumps that oil back to the tank. So maybe it's produced, 1,000 psi. After 1,000 psi, the relief valve on that pump just dumps, right? Because you don't want to put more than that amount of load on this 125 horse motor, because it could stop.
Oh yeah, we did. We managed to stop it a few times in testing.
Oh yeah, I have never seen a 125 horse motor come to a stop and just.
Yes.
It's like, what happened? And then pow, the breaker trips. It's like before you can even react, it would dump that motor.
Yeah, because we'd punch the e-stop and it would already be out.
Yeah, but you couldn't get it fast enough.
Yeah.
And but we didn't. It took a while to figure out what was causing that. But let's go through the steps. You got the low pressure, high volume, low pressure being like 1,000 psi.
Right.
Then you got the medium pressure, which is going to take it up to I think it'll take it up to 3,000 psi with the other end, so that there's two vane pumps in this one cavity.
Okay.
Not one cavity, but one pump.
Kind of sitting beside each other.
Well, they assemble from each end.
Gotcha.
So you just buy a pump that has 2 different rotors in it and one common shaft. Right?
Yeah, yeah.
And it's all sealed up. It's got 2 pipes in, 2 pipes out. The relief valves are somewhere else.
Sure.
The relief valves are actually on top of the tank.
Sure.
to relieve back into the tank.
Oh yeah, I remember doing all the connectors on those.
That's right.
Yeah.
We had to completely fix all those connectors. Anyways, so it'll take it up to 3,000.
Sure.
Okay. And then, but what was happening was I'd get it up to 3,000 psi, and as soon as I'd go a little, I was trying to run the joystick to control the throttle valve on the hydraulic valve. As soon as I'd try to give it any pressure, you could stop that big pump. So it took a while. Now the way I figured out what was wrong was I called an expert on pumps, and he said, I'm not sure what's going on, but he said one surefire way to do it, and this is for all the viewers, one surefire way to do it is to take the relief valves out on 1 and 2 and see if it still does it.
Yeah.
So if it still did it, he said just take them out one at a time until you find out which pump's causing the problem, right?
Sure.
Which one's stopping the motor. So I took the relief valve on number 1, still did it. Took the relief valve out, I put it back in, took out number 2, still did it. Took out number 3, didn't do it.
No more problem. Yeah.
So, okay, so it must be number 3. This is number 3. This is the highest pressure.
Yeah.
But this thing can move almost 0 volume of oil. Now, we got to talk about why. A vane pump moves the same amount of oil all the time.
Yeah.
If it's all based on displacement, right? When the vane comes out, as it goes around, it pulls in a certain amount of oil as it's rotating. It sucks in a certain volume of oil. That oil maintains its place in there all the way around until it squeezes it out on the other side as the vanes go back in.
Sure. The oil's trapped in that vanes compartment.
That's right. So there'll be a discharge hole over here and there'll be a suction hole over here. So as this thing goes by, it'll suck in as it passes that cavity, suck in a fixed volume of oil.
Yep.
Right?
Same amount comes out the other side.
Pushes out same amount out the other side. Exactly right.
So if you need more, you run it faster.
Exactly.
Yeah.
It's displacement's based on. Oops, sorry. So we figured out that this was the pump that caused the problem. So we said, okay, what's causing the problem with this pump? Well, just to back up a little bit, I don't know if you remember or not, but think back with me when we first started this thing. This thing was completely full of water.
Oh yeah, everything was full of water.
I call it the underwater storage program.
Right. It had been.
It's great for hydraulics. It fixes all your hydraulic problems if you just soak them in the water for a little bit. Everything works better.
Yeah, if you consider that hydraulic includes water.
Yeah. And for those of you who don't know anything about hydraulics, just fill them with water and see what happens.
Right.
Okay, well, no, that's not true.
It's
This machine was a complete and total disaster because hydraulic hoses had been left open not for days, I'm talking years.
Yep.
It had been left open, and they put plastic bags, like bread sacks, over the end of the hydraulics and taped them with a rubber band. By the way, don't ever do that because bread sacks break down in UV light and they disappear. And then what do you got? You got a hose. It's a big funnel picking up water. So the hydraulic tank on this thing, we probably took 55 gallons, 55 gallons of water out of the hydraulic tank that feeds this pump.
That's crazy.
And I don't know if you remember or not, but that tank's about,
I
don't know,
the
5
tank's
foot tall.
It's the size of a person.
So, and the discharge, of course, is not right on the bottom. It's probably yay far off the bottom, right?
Sure.
So that way you don't suck trash off the bottom of the tank, which is a good idea. So there's a big suction line coming out like that. Well, it had so much water in it, the water came up to the height of the suction line. Now, none of this had been apart, right?
Yeah.
This had hard lines going to all these inputs and outputs. Yes. You had hard pipes,
sure.
Not hoses.
Yeah.
It was welded fittings and a little expansion joint at the tank, right? Well, of course, there was so much water in it that the water came down the suction pipe, and as it does, it floats the oil out ahead of it, right? The oil just goes up because the water comes in under. Comes into this, okay? So all the pumps had water in them. Now, we didn't know that.
Yeah.
We just drained the water out. We didn't know how much was in it. We didn't take any of this apart.
Right.
And when I first turned the motor on, I heard a bang, and then it took off, right? Well, that was breaking loose different parts in the vanes, because they were stuck.
Yeah.
And probably the vanes, what happens in the vane pumps, if those vanes are stuck out and this chamber gets rusted below it, it's got to jam them back in so it can rotate. Okay? So
they popped back in and made a couple of rotations and kind of cleaned itself up.
Well, and we'll show the viewers here in a minute some of the rust damage that was done in this.
Yeah.
That has cleaned itself up just by running, because we've ran this thing for hours. Right?
Sure.
So just for anybody who's watching the video, you have video of it running. I mean, we ran it for hours until it started busting hoses and shooting oil everywhere, and I set it down because it was too dangerous to operate.
Right.
And I told the owner, I'm not fixing this thing until you fix this. And I said, it had a fitting, for instance, that whoever welded on it looked like they'd been using a mud dauber, could have done a better job with some dirt and some water.
Yeah, there were a lot of line and connection issues for sure.
Well, not only did they take a fitting that looked like this, that had a hydraulic hose or hydraulic pipe welded in the center. As they welded, and it has a flange sticking out where they re-welded it, they just welded right over the bolts.
Oh, yeah.
So the bolts are welded into the thing. You can't even take the thing off. I mean, that's how stupid the people were who were working on this.
Yeah.
And I'm told I should fix this thing for nothing. And it shouldn't take me any time. Well, everything we worked on this thing was one failure after another like that. And when the main hydraulic discharge line coming off the pumps starts shooting oil 20 foot in the air,
yeah, for sure.
Done.
I mean, that kind of pressure can cut somebody in half.
Yeah. So as those of you who know, hydraulics can be very dangerous when a hose breaks.
Yep.
So we don't want to have that kind of danger. So I told him I wouldn't do anything, even if I fixed this stuff and he paid me for what he owes me, which to date, he hadn't even paid for any of these parts.
Yeah.
Which he told me to buy. And, on a text message, he said, you want me to buy all this stuff? Sure, buy it. So I bought it. It took 10 months to get it. Mm-hmm. In the meantime, he's changed his mind, doesn't want to pay. So that's another issue, and we're letting the court system deal with that. Understanding that this may get resolved, and he wants his pump back together. This is what we're doing today: is to review that pump. Okay, so this particular pump is what we call a count them. Here's how many pistons you got: 1, 2, 3, 4, 5, 6, 7.
Okay.
So it's a 7 piston. And this is a variable volume pump. So you say, hey, it's got pistons in a cavity. How does it vary the volume? Well, it's really cool how it works. This is a rotating cylinder. So this piece is actually driven. It rotates by this main shaft right here as it turns.
Yep.
This is rotated by the motor. And as it turns, we'll show you the pistons and so on. But as it turns, it sucks oil in. So this is the piece that rides right here on the back. Okay. So this will be your inlet, right? It's got a big suction and a smaller discharge, right?
Yeah.
So it's got a big suction. So as this thing rotates, the pistons go by this hole. It can suck in fluid, right? Oil. Mm-hmm. Then it pushes them out over here. So you say, how does that control the volume? Well, this cool little thing.
I think we should also explain that as the piston is passing the inlet, it pulls down, right? Is it on?
Well, the pistons, here's the thing. Here's what I want to show you.
Yeah.
Okay, so let's imagine, for the viewers who are watching this, let's imagine that the drive shaft is right in line.
Sure.
Right? The drive shaft is coming straight in here, and this is rotating in a perfectly parallel to the input shaft. As you can imagine, if it's rotating like that, are the pistons moving? Well, in fact, the pistons don't move because the pistons stay in the exact same location as it rotates, right? The cool thing about this pump is, let's say this is the level position and the shaft is level, right? And this thing is rotating at 1,800 RPM, right? No oil is going to move if this is perfectly level.
Right.
Right? But what happens is, this is controlled by pressure. As the pressure goes down in the system, this thing comes down like this. So there's like a U-joint, basically. The pistons act as a U-joint, and it rotates like that. So then what happens is, as it's rotating at an angle, it sucks oil in the piston one way, and then as it goes around the other side, it squirts it out.
Like a plate on the bottom that makes them go like that, or angle the whole assembly, which puts, the top pistons way farther out and the bottom pistons in. That makes sense.
Yeah, you're talking about like a wobble pump.
Yeah, a wobble pump, but you'd have just that little
plate, if you will.
Yeah, the plate on the bottom.
The plate is rotating, and then you hydraulically control the position of that plate.
Exactly.
And when the plate is perpendicular to the shaft, the pistons are just rotating as a mass without moving. But as you start to turn the angle of the plate, and the plate starts to move over like this, still being driven, rotating, then the pistons are moving back and forth because they slide this way when they come around the plate, then they slide that way, so the pistons are moving back and forth. And it's like a frigid air pump in General Motors air conditioners, for instance, in the old radials that I used to rebuild when I was a kid.
But now this one makes sense too. You move the whole assembly, and then you've got a piston that's farther out and a piston that's farther in, and the
sucks it in on one side, pushes it out on the other. Okay? Yeah. So now that's the easy part. So this thing sits right in here like this, and you can see from here, see the angle of the pump assembly? So here you can see, these are all the pistons.
Yep.
Okay. Now you can see this thing had been underwater, and see some of these didn't have any water damage. See that in there's perfect.
Yep.
Right. It's just as shiny as can be. I'm probably in the way.
Oh, you're fine.
You can see
that these ones look.
See how shiny that is all the way around?
Yep.
Right. Then you'll see some of these that had water in there, and there's rust on the end. And in fact, I don't know if you have enough light to see it, but there's several of these that have some rust staining. Now, I'm not worried about that staining. It doesn't affect the pump one iota, right?
Yeah, they feel great. You can't feel any issues at all.
Yeah, I mean, it's stuck in the bore. But these are the piston rings, right? And those piston rings, there's 2 piston rings on every pump. they run in these bores. And if we look in these bores, well, we ran it enough. If there was any damage,
It cleaned
you
it
can't
up.
tell. Oh, they're just, they feel like they're brand new inside. Now, this is probably hardened.
Yeah.
Very hard.
Right.
Right? You can tell by the color.
Sure.
So because it was very hard, the rust didn't cause any damage.
Yeah.
Right? A very, very hard steel. So it, very high carbon content in this, right? Which made it hard. And there's a tiny bit of rust in just one right at the very end, right? Mm-hmm. That's the one that probably got the water in it. That's the one right there. But I'd stick my finger, look, there's the end. I can't go any farther.
Right.
And if I pull my finger back, it's right there at the end. So, hey, one piston is a little compromised. But that don't matter because it's a variable volume pump, right?
Sure.
And it's still going to make enough pressure. There's not enough slippage on that one because the rest of them are all putting it out.
Right.
Right? So,
yeah, hydraulically it's going to compensate anyway, even if one,
That's right. So they've got one little spot right there about the last quarter inch,
yep.
Probably where water set in it when the piston was back.
Sure, it was
I can feel it's perfectly smooth back at this knuckle.
Yeah, it was the one on the bottom or something like that.
Right, got the water into it, right? And the rest of them are just brand new. So, we could replace this, but the rotating assemblies, they call this the rotating assembly. If I buy this and the pistons and the plate and all that, we got to spend another $5,000, probably $4,000 on a kit.
Sure.
For a Rexroth.
Yeah.
I mean, this stuff right here costs $3,000.
Right.
Not including this. Right? Just these pump parts. And took 10 months to get them.
You buy a whole LS engine.
Yeah. I mean, there's a lot. So I don't want to buy this. So how does the compensator work? Well, this is the block that bolts onto the back.
Sure. Kind of the pump head.
The back end of the pump. So as you can see, this is your suction. This will be your discharge, this little slot right here. Right?
Yep.
That lines up with this one. So This is the outlet, and you can see how small that is?
Sure.
That's your high pressure outlet. Here's your suction, which is the big opening, right?
Okay.
That's the suction side. Okay, so this goes, let's put this way down. Make it easier to see. You gotta watch your fingers because this will hurt you. So this piece goes right in here, just like that. You can see how it slides back and forth.
Sure.
Right? Okay, so when it's dead centered, it don't pump anything.
Right.
Now, there's always leakage.
Right.
In the system. There's leakage around the spool valves. There's leakage. So does it ever go dead center? Well, probably not. It's probably got just a little bit, so it's moving just a tiny bit. But what was going on before, the reason this 125 horse motor would come to a complete stop is when we come up and deadheaded the crusher.
Yeah.
Right? When it come up to where it was too blocked, where it come up against something where it was starting to smash metal.
Mm-hmm.
The pressure, takes a lot more force.
Sure.
So it'd come up. Well, the relief valve, there is no relief valve on this. The relief valve is the compensator.
Okay.
Okay. Since it didn't relieve.
It relieves internally.
It relieves, it does it automatically, right?
Right.
But that's zero. It's not going to pump any more pressure.
Sure.
Right. So, and you control the stop position of this with the hydraulic adjusters, which are these. Right?
Yes.
They screw in right there. Right. Now, one of these was broke clear off, and it's kind of because, these guys have been pushing this thing around with a track hoe.
Right.
And one of these was pushed off, and one of them was bent.
I remember seeing the bolt bend on the end of it.
Like this whole assembly.
Yes.
The whole assembly is got a bend to it, right?
Okay.
That's because they hit it and bent it, like when they're trying to put the thing together with a track hoe.
Gotcha.
Okay. So, anyways, so I had to buy these. They're here. Here's the whole assembly.
Yeah.
You can see in there. There's a brand new. And I couldn't buy just this. Rexroth wouldn't sell. I said, look, my assembly's perfectly good. I just want this. They said, sorry, we don't sell that. You have to buy the valve assembly.
And the rest of it's the spool valve and the spring. And
That's right.
It's all in there, right?
Yeah, the whole thing is in this one assembly. And they wouldn't sell it to me otherwise. So, okay, I got to buy the thousands of, $1,000 or
sure.
$1,500.
I mean, it's a nice piece. It's all machined and.
It took a year to get. It took 10 months. 10 months after we ordered it.
Exactly.
I called Rexroth every couple of months. Said, where's my part at?
Well, they had to find the one old guy that worked on this pump in the machine shop and have him machine one.
Yeah. Well, it's definitely buy build.
Yeah.
They don't have parts on the shelf for this thing.
Absolutely.
Okay, back to the pump. So, like I said, this thing is always going to be compensating for the leakage. So it's going to go right up to the set pressure. Now, if I want to run 4,300 PSI, what I do is you adjust this, right, in and out, until what it does is it maintains this thing just at the right spot, right? If I want more pressure, I tighten down the spring, and it'll push this down a little bit, make it pump a little more, and then compensate back, right?
Yep.
Okay, so that's how this adjusts. And just by moving this part right here that's rotating, it's sitting right on there as this thing's turning.
Right.
It's either turning over here and pumping a amount of, a huge gob of oil.
Yeah.
Or when the pressure comes up, it automatically swings into position and pumps less oil. Okay, so lastly, what controls this? All right, I knew you'd ask. So, okay, so what controls it?
Well, this is the whole thing we've been talking about here, that it can compensate internally.
Yeah. So when we got this thing, we thought, why was this not moving? Well, as you can see, these parts that were bent, they weren't keeping it from moving. They were just damaged.
Right.
Right. What was keeping it from moving, again, was the underwater storage program. A lot of damage. So here you can see water damage, right? Now, it's not going to hurt it because the business end of this is this piston right here with these piston rings. So any little, if there's any little rust pits or things in there, all it does is what?
Well, nothing, right?
What's it do? It holds
oil. Yeah.
Right.
I was like,
don't hurt a thing.
Yeah.
Right? It don't hurt a thing. So here's the bore right up here at the top. It's just a piston bore like a cylinder on a car.
Sure. Yep.
Right? And that piston bore, it looks brand new, right? Because this was up high.
Right.
Right? The oil was down, the water was down here in the bottom. Come in right through this suction port and filled that thing. So happily, it didn't ruin this bore. Otherwise, we'd be buying the whole pump.
Sure.
But why wouldn't it compensate? We had to drive this out with a sledgehammer.
That's crazy.
Yeah, this rust had grown this thing into position.
Yeah.
So this thing goes, I'm not going to put it all together today because I'm not getting paid. But when I get paid, if he pays me for this, I will put it back together for him.
Yep.
And this is not for your, anybody who's skilled in the process of building pumps will know how to do all this, but it's not for your, your average V8 mechanic.
Right.
Unless he knows how to do all this. And they can figure it out. But anyways, this slides up and down right in here. So this goes down. Oh, I didn't show you the other part.
Well, we could.
Here's some more damage. So this piece, so what happens is this is hydraulically driven, right? It's a cylinder, it's hydraulic driven.
Yep.
So here's a big piston, the big spring. That big spring's sitting on the bottom. Now the bottom of that spring is gone.
Yeah, rusted off.
It was completely rusted off. So I got a brand new spring over there, right? That's never been opened. That's a new spring. So anyways, this is trying to drive it up, right? And so the hydraulic pressure is compensating against this spring, right? Trying to push it down.
Sure.
It compresses that spring, and then to make sure that this thing starts pumping when it's turned on, the spring pushes it out, so at least it'll start moving oil. And then when the pressure comes up, it pushes down.
Pushes back down, yeah.
So the hydraulic pressure now actually comes right through there.
Okay.
And it comes down through the center. The center of this is hollow.
Yep.
Okay. And then it comes down to this little device. Oh, what is that? I'm glad you asked. This goes right in here like this, okay? And this piece is actually what controls this is your feedback mechanism.
Yep.
To tell you where it's at. So what happens is, at low pressure, it might push this thing way out, right? This is sliding, and by the way, look at the damage on that.
Yeah, I know, that's the worst.
It's trash. This is a precision
I guess now you can actually see its travel, but it's from there to there. That's how much it moves. And it's
Right.
not sliding up and down all the time. It's only sliding when the compensator moves, right?
Exactly.
So you don't have to worry about a bunch of wear up and down that shaft.
Well, yeah, and it's complete. There's oil actually squirting out that little hole.
Yeah, so
in the
it's
center.
riding on an oil bearing, basically.
Exactly, an oil bearing. You got it, perfect. And that little shaft is hollow, right? And it's got little rings on that to help it not pass oil.
Sure.
Okay. Well, we had to drive this out. I beat the snot out of that to get it out of there because it was all rusted in place. It looks good now, but I had to beat it up to get it out. That sits in there like that. This goes in here. Now, this all has to be assembled once you get it in. So first of all, you drop this down in the hole. Then you put this back in.
Yeah.
Right? So imagine that's going to sit in there like that. Okay? And then this piece, which is going to ride up against that, we stick that back in here. Okay? And bring it up here. And then we have a precision bearing. Right? There's a needle bearing.
Yep.
Like a piston pin bearing on a two-stroke.
Sure.
Right? That goes right back through there, which sits in here, which lets this run frictionless, right?
Yes.
So as this thing goes up and down, if I have a hydraulic pressure pushing out here,
Yep.
right, I have a big fulcrum which can compress this spring,
Yeah.
right? So it'll push, actually.
We should show the springs on the spool valves, but
here's the big spring.
here's
right?
a full setup.
These big springs are going up here,
Yeah.
right? And they're trying to push it down. So the springs are trying to push it down, right? And they have a great amount of force because of the distance from here to here, right?
Yeah.
But as it comes up here, it has less and less force, right? So that's your feedback mechanism. As this sets still, right? And this slides up and down. So the hydraulic pressure down here, if it's down low, a little bit of pressure will compress them springs. But
Right.
as the pressure comes up, and it starts feeding more pressure in there,
This
comes
has
up.
less and less power to push out on it.
You got it.
Yeah.
And so this is just a balancing system, right? It's the size of this piston. Actually, it's the size of this little piston, right?
Yeah, the tiny.
It's the surface area on the end of that.
Yep.
Is pushing, and because it's all about it's all about the diameter, right? It's surface area times pressure gives you the amount of force that this is pushing out. Well, anyways, this actually was frozen into here, wouldn't move. It was all locked up because there was rust on this, and I shined it all up trying to save it, which I did on most of the parts on this big machine.
Right.
But I couldn't save this.
Right.
I couldn't save that. So, anyways, that's how this works by sliding it up and down. As this thing, I didn't show the good part. So the really cool part is
the pen.
This goes down in the machine. You got to put this towards me.
Yeah.
Comes over here. So this fits right in here. It's pretty precision, so you got to be very careful. Slide that down in there. I'm just going to set that right on that ring. This rides back in here.
Yeah.
See that pin right there, that hole? That we'll show it to the viewers like this. This fits back in here. That centers up right in the center.
Mm-hmm.
Right, and then we put this piece.
That bolt drives in.
That bolt drives down in, and that bolt sits right in here.
Locks it in place.
And hold that. So now this piece is basically sticking out of that slot right there.
Yep.
And it's moving up and down, right? So as that moves up and down,
it moves the plate, the swash plate.
It rides right in there.
Yeah.
Right? So it pulls it up or pushes it down, pulls it up or pushes it down, which is controlling the position of this guy.
Yep.
Okay. And so that's it. So we have lots of new parts. This part had to be made in Germany. You can see I haven't taken it out of the package because this has got that very nice packing plastic on it.
Yeah.
So that's the new piece for that we ordered. Here's the new pieces to replace the both of these pieces, which were the key pieces to operating the pump.
Right, and that's how you control the pump's pressure anyway.
Yeah. Well, there's the volume.
Yeah.
And a pressure.
Okay. One for each.
One for each. So.
And then why do you need to set the swash plate limit then with the mechanical limits?
Well,
just to make sure it doesn't.
Make sure it doesn't
come apart.
Well, and also, it sets your maximum volume.
Oh,
right?
okay.
You don't want the maximum volume to be so high that it overloads the pump.
Sure.
Right, because it is pumping at a low, even when it's fully down.
Yeah.
It might move so much volume that it would put much more pressure on it than the other vane pumps.
Yeah.
So you limit how far the swash plate can move, right? And you can actually set the maximum pressure. I mean, you can set it to it didn't go all the way to neutral, where it kept some pressure.
So it's always pumping. Yeah.
It's always pumping. Of course.
Yeah.
We want it to be able to go to zero.
Of course.
And so that's it. As soon as I get paid,
yep.
This pump can be reassembled, and until then, it's been sitting on a pallet. And it's not going to go together. So there's
racking up storage fees, huh?
Well, I wish racking up something.
Yeah.
So this is all. There's this new seal right here. That's this seal.
Yeah, it is compromised, right?
Oh yeah. Well, we'd never put it back as much as it cost.
Of course.
I got new O-rings to go around different parts. These are every one of these. There's that new piston.
Yep.
With the compensator piston in it. That's brand new. Every seal and O-ring that was in this thing. Well, those are brand new piston rings for this.
Ah, yeah.
I went ahead and bought new piston rings for it. I just didn't want to take a chance, right? So I bought every O-ring that we had out around all these little components.
It's not a pump you want to tear back down. You need a tractor to lift it almost.
Well, they took it. Yeah, the owner took it out with their track hoe.
Okay.
And or not the owner, but the owner's representatives. I told him this thing had to go to my shop, and so their guys took it off because it's heavy.
Yeah,
it's
super heavy. It's two guys to lift half, so we can't lift all of it. I can guarantee you.
I don't know what this weighs, but it's a solid block of cast iron. I mean,
yeah,
it's like picking up a Toyota engine. Oh gosh, that's got to be 100 pounds.
Sure,
it may be 110 or 115, but there's a bunch more of the little O-rings that are in these bags.
Oh yeah,
those are all O-rings to transfer oil around to different spots. Like oil comes up and goes over to drilled. See.
I see.
Drilled from one side to the other. So those go on there, so on. There's an O-ring right there.
Yep.
So, we've got all the parts to put it back together. If the owner ever decides to pay me,
yeah,
he can get his pump back. And until he does, I'm going to get paid for all this and for all the work it took to take it apart. So he quit paying in the middle of the project and decided he didn't want to spend anymore. So we just quit working on it.
And
So,
you got new amp meters for this pump?
no, actually
Or these were just bad in the panel?
they were bad in the panel, and it's a good question that you asked. These are the originals that go back in it exactly like it came, and it shows the voltage going to the 4 to 20 control.
Oh,
because
that makes sense.
You can actually control the pressure or how far, this thing's going to go to 4,300 or whatever the set pressure is, but you can control how much of that gets applied to the piston.
Okay.
So you can zero of it, so it all returns to the tank, right?
Mm-hmm.
Or as you push forward on the joystick, right, or turn the knob or whatever, you tell it to go. You can control how many milliamps. And as you'll notice, this is a milliamp.
Yeah, I saw it only went to 1 amp. So
yeah, it's a milliamp meter, so half an amp. So this shows the voltage going to the hydraulic coil.
Yeah.
And it shows the amperage going to it, so you can control them. Well, obviously, whoever took care of it didn't take care of it. And these glasses were all broken. And these were all bad, and
they
couldn't trust them if they worked or not.
Full of dirt. I remember that.
They were filthy. So I bought them, and then there's one bad switch in the panel still. I changed every switch in the panel, except for this one. This is the last one I had to buy, and that's all the parts to fix that switch. So, everything's here to put it back together. And
we can finally put to rest what happened to the car crusher, because you guys keep asking and I keep not telling you. Because I didn't want to talk about it. It's tough to talk about it.
Right.
So that's what happened to it. It's sitting here. Well, the last important piece is sitting here ready to rock and roll.
So everything's here, ready to put together. There is some things that'll have to be done before the thing will run.
Yeah.
The owner forbid me from having you do any more filming.
Oh.
he didn't want. He said, "I don't want your son in here doing any more filming."
Well,
I said, "Okay."
That's the deal. You get free labor. I get to make a video, and it works out. But
he didn't get charged for it. But
yeah, exactly.
Regardless,
exactly.
I thought it was a good deal for him. But
a ton of free man hours. I replaced all the connectors on this bad boy.
Yeah, that was like, I don't know how many there were. You worked at it for. It was hours and hours. That's one of the hydraulic connectors to one of the valves, and I know you spent hours out there with me. I spent a lot of hours out there when you worked there.
Yep, I know.
And working by myself, sometimes till dark.
Mm-hmm.
I locked up the salvage. I locked up the iron yard at night. I had to sometimes they locked me in.
Right. I mean, I had to come save your truck there in the middle of the night.
Yeah.
Wasn't it? Didn't the shifter cable come off? I forgot what happened. The van broke.
The shifter cable broke on my van. I forgot that till you mentioned it.
Yeah.
You had to come down and get me.
I was like, I got tools.
So we fixed it in the parking lot, didn't we?
We did.
Yeah.
You drove it home.
So, there is some very important things that have to be fixed. Putting the pump on is just step one.
Yeah.
But the pump rebuild gets you almost home.
Yeah.
Right? Putting this back on and this back on, that's a couple hours of work to finish that up. But then there's a lot of work left, right? All them hoses are broke. There's hydraulic fittings that are broke.
Every one of those hoses costs a ton too, I'm sure.
Well, we put thousands of dollars of hoses on it. And then, some of them hydraulic cylinders that on that big clamshell that comes over.
Right.
Some of them cylinders are yay big around, big old rods.
Yep.
And when I put full pressure on them, I could see oil squirting out across the parking lot. And I thought, well, there's another cylinder that's gone bad.
A whole lot of rebuilds going on
there. It's just old seals, right? And just like they all go bad with age and have to be replaced. Well,
this car crusher was in a movie. I don't know if I ever mentioned it, right? It was in a movie about the time we were working on it. It was pretty funny.
One exactly the same.
Exactly the same.
Yeah,
same model. Not the same. But
this is a 500 ton. There was a 500 ton in a movie where it's crushing a car.
Yeah, exactly.
So anyways, that's the update. As soon as we get paid up, we'll put her back together and he can go
and you guys won't get to see an update on it.
And you won't get to see a video, but I can tell you about it.
Yeah.
Maybe I'll take a few pictures.
That is it for today, guys. Thank you so much for watching. Don't forget to head on over to shopwatchjrgo.com for cool shirts like the one I'm wearing under this shirt. And please like, share, subscribe, do whatever you want to do, and I will talk to you next time. Well, now we got to get this back off the bench.
Let's lay this back over here.
It sure weighs a lot. I'll tell you, this is a 2-man lift just for the piston side.
Can I just watch film while you move it?
I mean, if you have a crane that I can use in the meantime.